Now you can hear me. Cool. All right. Well, I hope you all are here for the real designing Salesforce REST APIs for microservice architectures. This isn't a restful mindfulness kind of session. This is going to be pretty deep. Hopefully, you'll get what you're looking for. I'm pretty passionate about this, but I'm also quite geeky. So hopefully you're all with me. All right? Okay, let's see if this works. Great. My name is JJ Jakubik. I'm Chief Architect of Velocity. And actually, as I go through these slides, let me make sure it's clear. I haven't posted them yet, but right after this, I'm going to post all these slides as PDFs in the chatter feed on this session. So you'll have copies of all these slides. I'm giving you a ton of references and URLs and stuff, and they're not very big. But you'll have the slides. You'll be able to get everything, OK? All right. So I work for a company called Velocity. Velocity is a premier app exchange partner. We build everything we do on top of Salesforce. We take Salesforce and we customize it for all these industries that you see here: communications, media, energy, insurance, health. We're working with some of the largest companies in the world. We're kind of a big company these days as it stands for App Exchange Partners. We're about 900 employees. We have hundreds of customers. Some of the largest ones in the world, as you can see from some of these icons here, logos. And what's interesting is many of these companies are actually working on microservice architectures at the same time that they're deploying Salesforce. So microservices and how this works is very important to myself and Velocity. All right, wouldn't be a Salesforce presentation without the forward-looking statement slide. I think you know the drill. Don't make decisions based on things that I might say that aren't shipped software. OK, this talk is broken into 3 sections. I think I'm dialed in to about 35 minutes. Let's see if we are. 3 sections. Microservice architecture overview. I want to make sure that all of us kind of have an understanding of what a microservice architecture is, which explains what we need the next sections. I'm going to talk about designing REST APIs and focusing on encapsulating what I'm calling internals. It's critical for proper microservice architecture. And then I'm going to give us some REST API design guidelines as well that kind of goes beyond that, what we need to do to design good REST APIs for microservice architectures. All right, so section 1, microservice architecture principles. All right, and to start here, I gave a talk a couple years ago at Dreamforce. How many of you were here? I'm sure all of you were here at that session. Yeah, I've got a couple hands. This video is still out there on the internet. You can find it from this URL. You can find it from the Velocity site. I'm not going to go into all of this, but this is, if you want more information, I'll give the URL again at the end. This is a good presentation, and so I describe microservice architectures in that section, and here's how it went. First, let's think about an enterprise software suite or application. It's automating a bunch of functions. And those functions then are interconnected, right? Because they're business functions. There's connections between this process and this other process. If I take that and I implemented it all in a single technology stack, I'd have a monolithic architecture, the opposite of a microservice architecture. Now, monolithic sounds like a bad word, right? But really, monolithic architectures can be really good. They start simple. They're really easy to start with. And it goes kind of like this. So if we drill into a monolithic architecture, what does it look like? We're going to have a tech stack. It's going to have a set of app servers, a database, other stuff around it, right? All the functions are going to be implemented in there. It looks nice and simple to begin with, right? And it starts that way. Developer productivity and performance is pretty good up initially because everything is at our fingertips. The code base isn't too big. I can see everything. I can make function calls. I can share data at the database level. I can do all kinds of things. Everything's very fast as well because it's running in the same memory, running the same database, same local area network. But as things get bigger, 2 things happen. One, if I need dimensions of scale other than vertical scaling, in this case, I can use a bigger box. But if I run out of money and I can't buy a box big enough, I run out of options with this architecture. Second thing that happens is my development productivity degrades over time because the size of this gets to the point where it just becomes difficult to work with. And as you can see, if you didn't notice, the couplings and the interactions with all this stuff just naturally will grow over time. Okay? So it gets to the where when I want to make a change to one of these services, the order capture service, I actually have to go make and change all kinds of other services that really shouldn't have anything to do with this order capture change, but because they're all interconnected, that's the way it is. And that slows us down, and I'm going to actually double down on this, explain a little bit more about why this happens. But first, let's talk about pizza. Okay, everybody knows Jeff Bezos. He's the CEO of Amazon. He has a rule called the 2-pizza team rule. He says that if you can't feed a team with 2 pizzas, your team is too big. And what he means with that is if you have too many people, the barriers to communication, you can't communicate as efficiently as you want to, right? A 2-pizza team is roughly 5 to 7 people, depending on how hungry they are. And so at that scale, you can talk to everybody. You can say, hey, Joe, I'm going to change this thing over there. You change that too at the same time. Okay, great. It all works, right? But if I was trying to do that with a larger team, it's difficult. All right, so back to our microservice architecture. When I want to make this change, I want to make the change with my 2-pizza team that is managing just the order capture solution. But really, in this architecture, I don't have a 2-pizza team for order capture. I have a giant team for the whole thing because they have to communicate very closely to coordinate these changes, and that's wrong, right? By changing one thing with a 2-pizza team, I have to feed pizza to the fulfillment and inventory system teams because they have changes they need to make. But really, I don't know. I got to feed pizza to everybody else because they may have to change. I don't know that if they have to change or not. Way too much pizza is required to make any change, and everything slows down. All right? So Jeff Bezos found himself in that predicament in the early 2000s at an offsite, and they were talking, his lieutenants were talking about how to improve communication. He said, no, we're going to break this up. We're going to re-architect our software so that we don't have to communicate at such high fidelity. So we're going to organize our services in a smaller fashion, and we're going to integrate over a loosely coupled architecture. So what we're doing is taking these same functions, and now we're implementing them in their own separate deployment stacks. And we're going to still integrate our functionality. So each of these services are going to expose data and functionality to other services in the architecture, but we're only going to do that through service interfaces. And by doing that, we magically make our lives better. And it can make our lives better, but only if we design it properly. So the benefits, if I break this up, I'm able to have more options for scaling. You know, I've got a service interface to inventory management. If I need to shard that and break up a bunch of boxes, I can easily put that behind a service interface and scale that way. So it opens up more options to scale. I get back directly to the developer productivity. So now I can make that architecture change with the 2-pizza team, and I don't have to talk to all the other teams, assuming we've designed this properly. Now, the rest of this talk is really about how to design it properly. So let me just drill one level deeper. When we look into the microservice architecture, here's what we're doing. I'm standing up a little tech stack, smaller, right? It's got app server functionality. It's probably containers of some kind. It has a database in there as well. I'm going to create one or more REST endpoints that expose data and services from this little component to other things. I'm going to do the same thing for other components. And then I'm going to begin to integrate these components through service interfaces. And all these little arrows are service calls from one component to another. They're calling out to the rest. And we've loosely coupled ourselves now. This same mechanism also works for streaming. One of the things when you're doing microservices, you really do need, to do it right, you need to have a separate database in each component. Now, you may break the rules a little bit here and there and kind of do that, but it's easy to couple yourself to another component when you're sharing a database. So you really need to copy things, and you end up copying data, synchronizing data back and forth. Data streaming using something like platform events, Kafka, or whatever, you can also design a good message that insulates the clients of that from the producers and allows you to still change. I'm not going to go deeper into the data streaming side, but the same concepts apply here. And finally, a little concept from domain-driven design. It's called bounded context. APIs need to be client-oriented, stable, and backward and forward compatible. Basically what this means is each one of these interfaces is really a window into the inside of the component. You don't want to build that as something that exposes the inside. What you want to do is give to the client an API that speaks their language, providing really what they care about, ignoring what else you have in there that they may not, okay? The next section is really all about this. Okay, but one last slide before we get into that. While I'm here, I want to make sure it's clear that no architecture is perfect for every situation. Microservices is kind of the latest fad, but microservices has some drawbacks. When I'm doing this, the first thing that I'm doing here is, what I'm really doing is distributed computing. And the first law of distributed computing is don't distribute your computing, because it's difficult. It just makes everything more complicated. All your deployment and testing and operations become more complex. Often with these architectures, you're automating the deployment and setup, which is a great thing to do. You have to do it for this to work. Otherwise, it's unmanageable. If you had to manually spin up these instances, you couldn't do it, right? Okay, so you have to automate, and that's a good thing, but it's required. You have all kinds of questions about how big, how micro does my microservice need to be? How big should it be? Did I get it right? Did I get it wrong? You're integrating with these things across a network, be it local. Sometimes you're integrating with services that are out on a platform as a service across the internet. These connections are unreliable, and so you have to code for that. If I make a call out and I don't get a response, I need a retry or something like that. That makes everything more expensive. Distributed transactions are really hard, guys. We need transactional integrity in many cases, and if I try to, two-phase commit, three-phase commit, whatever, multifaceted commit, it's hard. So you end up dealing with all kinds of issues like that, and then forget about security and identity management and everything. So don't go into this lightly. Don't think that, oh, I'm just going to do this and it's going to solve all my problems. Use this where it's appropriate, understanding there's some drawbacks. Okay. But we like microservice architectures. We want to use them. So we want to design REST APIs for our services that preserve the benefits we're trying to get out of this architecture. So this section, we're going to talk through that. So it's all about encapsulating internals. And the first question there is, where do I break these things apart? Because that's where my interfaces need to go. If they weren't broken apart, I don't need any special interface. I can use a function call or share some database or whatever. When I break them apart, that's where my interfaces are. The single responsibility principle is a great way to think about how to break apart your services. You want to use this. You gather together the things that change for the same reasons and separate those things that change for different reasons. The reason we're doing this is so that when I need to make a change, I'm doing it in one place. I'm not doing it elsewhere. So if you take something that really changes together all the time and you separate it, you really didn't achieve anything, because when you change this, you're going to change that anyway. On that, you should put them together, because they're always going to change together. But if that changes and something else doesn't really need to change, we can separate those. That's convenient. All right? Beyond that, just keep in mind, we're trying to improve our developer productivity, so we want to be able to make changes with 2 pizzas only. If you take nothing else away, microservice architectures are about pizza. So when you get hungry, it's like, oh, it's a microservice. All right. The other thing I might use is scaling options. If I have a component maybe that's very batch heavy, and that it follows a single responsibility principle, something that's very batch versus something online may have different scaling parameters, and so it might be appropriate to implement that separately so that I have different options for scaling. Just another idea. Okay, now I've kind of decided that I want to do this. I want to give you guys an example of where this has happened. I'm kind of an old guy. I remember the day when all TVs were just one box. The monitor was there, the TV receiver was in there. You got one thing, even if it was kind of 2 components. And all the vendors would talk about how great their particular video standard was or whatever. It didn't matter because you bought it together. But then when home theaters came around and technology in TV monitors and receivers started changing very frequently, it became convenient to break these things apart. So you wanted to buy a separate TV monitor at a different time than when you bought your TV receiver, your audiovisual receiver. But as soon as I do that, it means that I've got to get video signal from my receiver to my TV monitor. And these things need to talk, and I don't want to have to buy them from the same vendor. I want a standard there, right? and I want to be able to change my receiver separately from the monitor. So these days, we've evolved to an HDMI standard. We have a little HDMI plug. We can connect it to the receiver and the monitor. What happens then, that receiver is receiving signals from various sources. It has God knows what kind of video representation in memory. It's probably digital, but it's got some sort of crazy, wacky format inside. It doesn't matter what that format is, because it's going to, at the end of the day, emit the signal across its HDMI output in the format that's according to the HDMI standard. So it has an interface that it's emitting to. And that client, the TV monitor, expects it. That TV monitor expects video coming in a certain format, and that monitor is going to do whatever it wants to with that signal, but it doesn't matter because when it talks across the wire, it's using that standard, all right? So in our case, we're not necessarily dealing with industry standards, but we need to standardize our interfaces between these components so that we don't have to change both sides of the equation at the same time. All right, so let's apply this to our code. We have service A and service B, and I just do a get against the object model of the service B, and I'm good to go, right? Wrong. This is internals of the service. And when I'm accessing the direct internals, when I want to change those internals, I'm breaking my service A that depends on those. So I don't want to do that, right? What do I want to do? We're going to create an interface that is separate from the internals of service B. This is really important. This image is an important one. We're specifically designing something different that is going to be what service A depends on. Now service A's dependency is on this REST interface. It's not on the internals. This REST interface, that little icon there is a JSON blob of some kind. It makes a GET call against some resource. It gets some JSON. It depends on that. As long as that JSON structure and the values it gets don't change, it's happy. I can change anything I want in this service down here. This is good. For example, I go from version 1 of service B. I can change it to version 2. I didn't have to change service A. I could take service B and implement it on a totally new tech stack, but I'm still emitting the same API I ever did. I don't have to change service A. I might implement that on Salesforce. And if I implement the same interface, I can still do that. That still works. So the component on the right side may not be a microservice architecture, but it can play along with my microservices architecture as long as it's playing with the right API. Okay. So let's start to think about these APIs. There's several things we need to design to make this work. First, there's the URL, which is really the identity of that message. This is exactly like a web page, of course. You're really giving the client a way to address something specific it's looking for on a network. Okay, so we've got the URL. That becomes the resource. The word resource is what that is. Now we apply HTTP methods on top of that resource. This is REST, right? So your resources are the things you're manipulating. You're using standard HTTP methods to manipulate those. Certain methods have request bodies, a put or a post, for example. You're going to send some more information to the server. Here's the thing I want you to create. You're going to pass that, so there's a request body. Don't forget about the headers. If you start to build your solution where there's header information that's an important part of the solution, that's part of the interface if you do that. I would try to avoid that, but if you did that, you've got to think about that. And of course, there's response bodies, again, JSON that comes back. This is what we're designing when we're designing REST APIs for microservice architectures. Okay, so one thing that tooling vendors tend to do is, oh, you've got some database or some functionality or whatever. We'll generate APIs for you off the database, and you'll be good to go. You'll be ready. Here's all the REST APIs you need to do this. This is wrong, though, right? Because if I've got an order object, for example, it's got an internal identifier that is private to that service. It has columns like paid amount _ C and payment token _ C. If I emit that directly as my JSON message, I've essentially exposed my internals, right? I've given away too much information to this API. And it basically means that, let's say the payment token at this point had to move. Let's say I implemented multiple payments for the same order. Well, that payment token and that paid amount might go to a child object. Now it's no longer on that object up there, and my API is broken because clients are expecting it up at the top. All right, so those are internals. I think that private identifier at the top and those column names, those are all considered internals from my perspective. What we want instead is some sort of implementation that has the ability to change what I'm emitting to the world from what I've got underneath. And you don't have to necessarily do that in step one, but it needs to be part of your architecture so that if I have to change something in the underlying implementation, I can remain backward compatible. I can still support the backward compatible functionality. So I think that generally means I need to think about designing that interface as a separate component from the actual implementation there. Now this means, and those things, I've abstracted my internals, and so now I'm in good shape. I'm better shape, right? I have the ability to separate. Separable is really the right word. I'm now separable. I can change the implementation inside without having to change the API. Okay, I will note that most Salesforce REST APIs emit internals. They're not appropriate to use for microservice interactions where I need to be able to change what's happening on the Salesforce side without having to change the other side. The SObject REST API, for example, I'm doing a get. I didn't bother putting the response body in here, but I'm giving the Salesforce ID in that. I have to know the Salesforce ID. If I migrate, let's say my company acquires another company and they were doing this, I now move all their data into my org. All the IDs of all the orders change as I move from the old org to the new org. And so all my clients are broken because they expect the previous IDs. The query REST API, I'm literally querying the database when I use that API. So it's not appropriate for microservice architecture interactions. Apex REST is what I want to use. If I'm using this directly on Salesforce, Apex REST is what I want to use, because that I have full control. I can code any kind of interface that I want. It's coding, and it could be hard coding, but I mean, not hard coding, but it is sort of hard coding. Difficult coding. But Apex REST is what I want to use because I can separate myself. Or I'm going to use something like MuleSoft or an ESD. I'm going to put a layer that's outside of the Salesforce service between my clients and Salesforce, so that I have the ability to change Salesforce here, and I can adapt. As I change Salesforce, I can change that little interface layer at the same time to maintain backward compatibility so that my clients don't have to know about that. Okay. I'm trying to get through so we have time for questions. I think I'm doing good. All right, so now I'm going to put all that together and kind of show it to you again, make sure that this is pounded home, because encapsulating your internals is really what we're trying. We have to do this. Otherwise, we're going to get this wrong, and microservice architectures are going to fail, and there'll be something else that we have to go to. Let's do this right. Okay, so we're going to use client-oriented. That means, APIs that are designed based on what the client needs, like this get product availability. Order capture cares about, is this product available? Can I order it now? Is it going to be back ordered? When might it be available? So I've got a product availability resource that it's going to request data from that happens to come from inventory management. Inventory management has some kind of wacky implementation in there. They're all about inventory buckets with statuses and on-hand good and replenishment and all kinds of things, but none of those details matter to order capture. All it cares about is this thing available, can I ship it? Can I request it? So there's some internal database structure. The inventory management component's going to do whatever it does and produce a response. That response is going to be a nice, simplified, and stable JSON representation. It's our separate interface. It provides that response back to order capture, and that makes order capture happy, right? It doesn't care about what's happening underneath. I can make changes there. Now, the other bit that's important is clients need to ignore parts of the response that they don't understand. And this is a reason why SOAP, in my view, this may be just my opinion, but in my view, SOAP, XML, kind of failed. WSDL, it failed because of WSDL. WSDL I change my service, even if I just add something. I add one field that I'm going to omit. I've changed the WSDL. Now I have to download the WSDL, get a new WSDL. These clients have to change, even though they could care less about the new field, doesn't matter to them, but they get a new one, right? So I've tightly coupled these two things when the whole purpose was to separate them, okay? With REST and JSON, that doesn't matter. There's no WSDL. I'm just giving you the answer. You look at what you care about, and that's fine. Okay. And now when I make changes, I may do all kinds of destructive changes inside, but I'm going to transform those to additive changes, non-breaking changes in my interface. As long as I can do that, all my clients are happy. They don't have to change. So this kind of looks like this. I go and add some things into the database. I add some fields. I add some child components or whatever. I can add those as additional elements in my JSON, and the clients could care less. There's more in there. I just, I ignore it. I don't care about it. It's fine. Everything doesn't break anybody, right? So this is how we want to make this work. Okay. So now let me give you some guidelines in how this should come together, and this kind of rounds out the design process here. We've picked our separable components. We've decided what kind of interfaces we want. We've sort of started now to need to think about how do we actually design the URLs and the methods and all that sort of stuff. I really like Swagger. It's called Open API now. This is, of course, a great way to document your APIs, but this is a great way to design your APIs as well because it puts you in the right mindset. When you're designing a REST API, you want to figure out what are the things that I'm going to enable clients to manipulate, to get, put, post, whatever. And then what operations am I going to support on those things? The things are resources. The operations are HTTP methods. And then what do the requests look like? And Swagger works exactly like that. Here's an endpoint on the left. I've got opportunities collection. I've got a second resource, really, which is the opportunity/optID. That's a single opportunity, which is different from the collection of opportunities. The collection supports post only at this point. The individual one supports get and put. And that's what it's telling us. So this is I won't go much more into Swagger, but I really like using Swagger. It puts us in the right mindset. Okay. Leveraging standards. Of course, this is REST. We want to be very standards-oriented. So first, we want to use the methods properly. Get is obviously a read. That means it's safe. So one of the things that's important about REST is every get needs to not change the state of the server. If you're very consistent about that, what happens is developers that are using it become comfortable that they don't have to worry about doing gets against your APIs. You want them to be able to do gets all over the place. As long as that doesn't change the state of the server, you're good. Now they can explore your API, at least start getting things from the API and be comfortable that nothing changed. It also provides certain semantics. Like if I have gets that are safe, I could potentially cache that information outside of the service because we know that that call doesn't change the state of the server, so it doesn't need to go all the way back to the server. If some component somewhere between the server and the client knows the answer, you can just give that answer as a cache. Okay. Post, on the other hand, is really typically create. Think create normally. It could be some special operation. If you're doing something like submitting an order for fulfillment, that might be something where I would use a post because it's patently unsafe. Unsafe means when you make that call, again, this is an unreliable connection. If I make that call and nothing comes back, I shouldn't just make the post again. What I should do is try to do a get and see what happened. Because maybe the message made it to the server and it just somehow didn't make it back to me on the way back. So I got to first figure out what happened and then decide what to do to retry. All right, so post is telling the developers this is an unsafe, it changes the state of the server. Put is also changing the state of the server. Think of this as update typically, but technically from a REST standpoint, it's actually creator update. In a put, if I know the URL or URI that I want that item to have, I can use a put, and it would be an upsert, essentially. If it's there, update it. If it's not there, create it. That's, according to REST, that's how that should work. Delete is obvious. Delete is delete. Okay. I want you to return standard HTTP error codes. A lot of times I see APIs that are developed, as long as the software didn't crash, it'll return a 200 OK, even if the operation didn't work at all, right? You want to return a 200 OK if everything's good. Whatever was asked for, create an opportunity. If that worked, it's all good. That is a 200, means, OK, we got it. In fact, 200 generally is used on gets in particular. I kind of like 201. When you are doing a post to create something, I like returning a 201, which says not only is everything good, but I created that thing you asked me to. You don't have to use 201, at least use 200. 400 and 500, these are our error conditions. At least give them a 400 or a 500. 400 means, hey, I don't know what the server's telling the client, I don't know what this request is, I can't figure this out. You got to do something different because I can't process this. The problem is on your side, client. 500 means, yeah, I don't know if your request was good enough, and maybe your request was great, but I've got a problem on my side. I can't do it. So, my service is down or something, so you give them a 500 saying, try again later. So use those. All right. Now think about consistency. Consistency helps everybody. We want our resources to be defined based on their URL. The URL to the thing really is the thing as far as the clients are concerned. So opportunities, for example, and orders. Those two I call them collections. I would expect if I do a get on opportunities, I'm going to get an array of things. Maybe it's all of the opportunities that I have visibility to. Or maybe it's my recent opportunity. Who knows what it is, but it's a collection of opportunities. Product availability might be more of a special thing. If it was orders/ID, I would expect to get one order, that particular one that I got, and I might get more detail when I ask for one in particular. We're going to apply HTTP methods on top of those, as we said before. I can get the collection. I can post to the collection, which might be adding one or more opportunities. If I do a post to opportunities, I would have the option of creating more than one opportunity in one call. If I want to, I could post an array, or I could post one. Put might do the same thing. You probably would post and put the individual thing as well. Okay, you're going to use a consistent standard for resource names as well. So I just went through that. A collection, an item in the collection. There's going to be, when you think about opportunities has child data. I'll go ahead and build the slide so you can take a picture. It has child data underneath it, like the contact list of an opportunity. To me, that's so important for the opportunity. When I get a specific one, I'd want to get that contact list right in that first request. Don't make them do a second request to get the contacts. So a number of these child objects just come back in this structured JSON. That's great. But then some things might be so complicated or voluminous that I want a different resource for those things, so potentially products. And I would implement it this way, where I've got now opportunities, here's the ID of that, and I want the products from this opportunity. That's what I'm asking for. That becomes a new collection, but it's bounded by the opportunities thing. Okay. And then consistency as well applies to across different methods. When I do a post here, I'm passing information to create this opportunity. I'm giving it a name. I'm giving it the customer, the owner. These things are somewhat abstracted, if you can notice. I'm not passing any IDs because I don't really know them. That post will be processed on the server, and a response will come back. And the gray things are really the same keys. The JSON is the same for all the gray stuff between the two. The create is giving me more information. It's giving me some IDs of things that I've created. It's given me some, the name of the owner with that email address. It gives me some more info. But everything that I provided in the post comes back to me in the same structure. That helps to reinforce this resource is this JSON structure. That's important. Okay. And the last bit here in terms of guidelines is interface versioning. So we're going to attempt to design an interface that we never have to change. But I've lived a long time. You live long enough. Even any interface that you design never to change, you're going to eventually have to change it. So you're going to want to put a version number in your URL for this next bit. But that version number is the version of the interface. It's not the version of the underlying service. So first off, I could change and even do a breaking change in service B to V2, but initially I could do that retaining my backward compatible interface, still V1, and no client need to worry about that. And if they don't care about that change, that could live that way forever. But let's say that's a really cool change and those clients want that. Well, we don't want everybody to have to get in a room with pizza to coordinate when we're going to make this change. So we want them to move over time, which means I'm going to actually stand up a second version of the same API that does the breaking change, moves the stuff that used to be off, those little tails on the top used to be longer, and now there's some things on the side, right? So I broke my JSON structure, but I did it by creating a new interface. Now I can have each service can choose when it moves to the new version of that. Eventually, everybody can move to the new version, and at that point, I can get rid of the old version. But this is how you have to work in a real serious microservice architecture. This is what you're doing. All right, so let's recap. Key takeaways. Microservice architectures require decoupling. You can't really do it. You're not really doing it right if you're not decoupling these services. Proper REST APIs are going to hide everything that's happening underneath. Okay, and then I can change without change. I can change the server without changing the client. I think Salesforce can do this with Apex REST or an ESB or an API gateway of some kind. We can do this. We're going to leverage standards. We're going to be consistent, and we're going to version your interfaces. And with that, I've got a last slide. I want to take some questions. We have 3.5 minutes left. Here's some things. There is a trailhead that could give you more information about Apex REST. On the right side, this is the session from 2 years ago. I don't want you guys to, when you're tired eating your turkey sandwiches next week, take 40 minutes or so and watch that. And then these Dreamforce sessions are really not about microservice architectures. If you just love me individually, you can go watch these sessions later on this week. Don't worry. But I am presenting there. All right, questions? Comments? Yeah. Can you come up, speak a little loud, microphone?
Or do you have like version 1 of orders, version 2 of products? What's the thought on versioning when you've got hundreds of microservices?
Well, you're never going to version everything at once. The whole purpose of that previous slide is you're going to pick what to choose. The goal is never to version the interfaces, so you're going to try to design an interface up front that you wouldn't have to break, that you can add to. And if you are just adding it, I don't update the version. If I go back to this slide, unlike Salesforce, where every time they do a new release, they're updating the ID, I would only do this if I make a breaking change. So the goal would be to go 47 releases of Service B without replacing V1. And maybe on the 48th, there's some new cool thing. I'll add a second V2. And so I only did that versioning once.
So this is applying to orders, but what if you have products? You're going to have products, right? So you're going to have version 2 of orders and version 3. Are all of those going to be managed separately?
Yeah, the question is really about you've got a relational data store with entities all over the place. Each one could version. I think you're going to encapsulate that up at the resource level. You really, by the resource, you're really versioning at that level. So it's you're building some things into it. There's an art to this. It's no scientific plug and chug kind of way. There was a question up here.
Oh, sorry.
Now it's working. He had a question, and then you're next.
Sorry, for a complex like a service that you don't need to change data, but you need an input like a complex structure that you need to get into and calculate on the server, and you want to return something out of it. How do you design that? Is it going to be like a get?
So it's more of a calculation service.
Yes.
It's not like a database-backed service, but here's a calculation.
That's right. Yep.
If it's the same thing can apply. Sometimes a resource, you need to make up kind of a fake resource. Like it could be a rating result resource or a ratings resource, where I send it a bunch of inputs and it's going to do some complex calculations and it gives me a response back which looks like data to the client. I don't care how that data was calculated, but it looks like a thing now. Even though there's no database back there, it still looks like a thing. So the resource is able to hide whether it is really data or not. Doesn't matter. I think you use the same principles. Hopefully that answers the question.
Hi,
Yeah?
I'm losing my voice, sorry. How do you handle, with Apex REST, the limited number of response codes they let you send back?
Well, I didn't give you very many response codes
Right.
up there, and they handle some of those. Like if the software crashes or the service isn't available, they're going to give the right response back for that. You're always, besides the HTTP error code, you're going to give some sort of error message response as well. That code is just an indicator to say, did everything go right? If everything went right, I expect to get a response that is actual meaningful. And I would be, it'd be crazy if it didn't, and vice versa. If there's an error code, now I want to look in and I expect an error body, an error response, not a good response.
Yeah, my backend developers are used to a wide array of HTTP codes, and I have to no, I can only do like these 3, sorry.
You just have to map them into it. Let's get together and let's lobby them for more HTTP error codes. Yeah, let's do that. If you're listening, Salesforce, we want some more HTTP error codes.
Yeah, so it's like maybe you are calling data for opportunity, you're getting data for opportunity, right? So, but you need calculation which is based on orders and other things. So what you are saying right now is you separate those services, right? But still you, in that call, I need that data, which you need to return. So are you saying that while I have information for opportunity, but for order information I have another service which I'm going to call from that call which I have received from there
Yeah.
itself? Is that what you are intending to say?
Here's what I will say for that.
Yeah,
I don't want your microservices so small.
yeah,
So if you can handle this with roughly a 2-pizza team, and I might throw 3 pizzas at it, I think it's probably okay. If you've got 50 pizzas, it's way too large. But first off, if you're that tightly coupled where opportunity calculations depend on orders that are in flight or something like that, maybe that needs to be together. The other thing, if it's just, it's too much, you could separate it by streaming some information, but what I do is opportunity doesn't care about everything that's happening in orders. It's just about, something about the orders is like, how much do they have on order now, or something like. So I would somehow encapsulate that answer into smaller, whatever it cares about, and I would replicate that potentially into the opportunity service. If we can't real time, and you got to be careful because these services, you're not running on in a big data center with fiber channel networks between these things. You very well may be going across the internet between these two. You don't have to, right? But if it was Salesforce, you would. So put them together. Don't break them apart if they're so tightly coupled. And if you have to, do something clever like that. Let's go.
Okay, my question is, you definitely hit the separation of concern, concern of separation, that pattern you went to. So my question is that, whatever you talked about, changing service BB version 2, you talk about functionality perspective, right? You can make a change and then your REST API cannot be changed.
Right.
Because it's a separate layer, because what you change a business layer, right?
Right.
If you talk about the model change, that may hit your REST API. Because now your model change, now your binding may disconnect.
But what I didn't show here really is, this thing there's an implementation of the interface as well. So imagine if I did that in MuleSoft, for example. I might change my underlying data model, and that interface has to change as well, but it's changing, that MuleSoft interface implementation is changing so that it emits the exact same interface as it did before.
But model change can include not including adding new fields. It could data type change. It could change the model of your JSON.
But if you have to translate it, often you can translate it back to the data type that was there before. Worst case scenario, we're doing this, worst case scenarios, occasionally you have to break something.
But my question is that you have to do the backup compatibility too. So what's your thought on that? You're not going to change that.
That's a good point where think about what your clients care about. Do I want a text field? That's all I care about is some message that tells me something. I don't care if it's a number or whatever. And then right in the beginning, even though it was a number or a date or something to begin with, all they care about is a text. Use a text. And then if it changes from number to, like it's an integer and it changes to float or something, it can still be text.
But you need to create 2 different services so that you have a backward compatibility, and then you need to do another REST API so that you can cover
Well,
the
we
new
don't,
one?
again, we're just using this architecture to try to minimize how much we're doing. And so
Okay.
I think generally, you don't have to solve every single problem.
Right.
Do the best you can. And if you
And
know, if you
another
have to do a few breaking things,
Another question I have is from the Salesforce.
this guy's giving me the hook.
Salesforce, so just one question. Salesforce web service perspective is that.
So I think what we're going to do
Okay.
is let's go out in the back. Yeah, is somebody else coming in here? Should I grab my stuff too? Or, okay, all right. Thank you.